Alright, so rates of change in linear and quadratic functions quiz. The hardest one, the worst one. We're going to go over it. We're going to try to wrap our head around it. Let's get into it. So, rate of change. The table gives values of the function f for the selected values of x. If the function f is linear, what is the value of f13? Now this one, from appearances, looks really easy, right? But then you realize you don't know the y-intercept. You don't know the slope. You don't know anything about this other than these values. So there's a few things we need to do. First of all, we read the question, we know it's linear, right? And we're trying to find f13. So we need to somehow go up from where we are. So there's two ways of doing this. Either we are going to take the slope, we're going to get, both ways require getting the slope, so we're going to do that. I'm going to get into which ways there are to do it later. For now, we need the slope. Also, this is a little acronym, RAVE. This is what's going to get you a lot more points on your tests. It's being thorough through your questions. First, we read and reread. We did that. We looked through all this. We found key terms. And a lot of times what you want to do is, if you see a term that you think is important, underline it. Because if it's important, you don't want to gloss over it when you're answering. Because you can go through like all these pages and pages of equations. I'm doing all this stuff. And then you come back and you forget what you're actually answering. You're wrong. It doesn't matter that you did all that math. You're wrong. So make sure to underline certain things that are important. I can't underline or highlight because I can't do that. But do it when you have a physical test in front of you. It'll help a lot. Second is read the answer choices. These are not that important right now. We'll do it when we're looking at to check. And third, visualize. That's what we're going to do right now. So if we have 3, let's just, I think I already screenshotted this, right? Yeah. Let's take this and look at it. So if we were to draw a coordinate plane like so, should probably draw this a lot higher up. We start with -3, -10, 3, -2, and 6, +2. I'm trying to put these all in the same straight line, right? So 3, -2, -3, -10. That's not a 3. Okay, so now we have our graph. This is what it's going to look like. Notice it's a straight line. We know it's a straight line because it said earlier this function is linear, right? So we're trying to find f13, which means we need the slope. How do we find slope? Well, if we can do that using the Pythagorean theorem, a lot more complicated method than it sounds. We're just saying, okay, to go from 3 to 6, how many units do we have to go? 1, 2, 3, right? 3 units. To go from -2 to 2, we have to go 1, 2, 3, 4. 4 units. Rise over run is our slope. That's it. All you have to do. Another way you could do it is using an equation. So you could do, it's 3 minus 6 over -2 minus 2. You can also do this using an equation. So you do, I forgot the equation for this. It's average rate of change equation. That is not what I want. Oh, yes it is. So we're going to do, so it's y1 minus y2 over x1 minus x2, right? So -2 minus 2 over 3 minus 6. because that's the x and y's of this and this. Right? Just load them in. And what we'll end up with is -4 over -3. Or 4 over 3. Useful if you don't have that much time or space. Both get the same answer. So our slope is 4 over 3. So what are we going to do with that? Well, one cheeky little thing you can do is, we're trying to get to 13, right? So let's go over here. The highest point we have, the closest point we have to 13 is 6, 2. If we are adding 7, so as x increases by 7, then that means y increases by 7 times our slope, which is 4 over 3. Right? And plus whatever we had, plus whatever we had. So this gets us 13. If we multiply these two, we get 28. 28. And then these are compatible, because 2 and a fraction aren't compatible. So I'm going to bring these out and just put it in a way that's a lot easier to see. So 7 times 4 over 3 is 28 over 3. Just multiply the numerator, right? And then 2 is just equal to 2 times, let's say 3 over 3, because that's just 2 times 1, right? So we have 6 over 3. Basic fraction math. So 6 over 3. Now we're adding these two, because we added here, and we're adding here. And then we end up with 34 over 3. Another way I could explain it is, if we're going from 6, 2 to a y value, something with the y of an x value of 13, so x value of 13, y value of x. I don't know what it is. Actually, I'm going to make this y, so that's less confusing. We need to get from here to here, we go up by, just up by 7, right? Because x is increasing linearly. But y is increasing by a different factor. Y is increasing by 7 times 4 over 3, because that's the slope. You could put this in y equals mx plus b. So you could do y equals, let's see, m is 13. No, m is 4 over 3. And then x is 13. And then but the only problem with that is you need your y-intercept, b. So that's why we did it this way. We just added the amount of iterations of the slope we needed to the y value just to get there, since it requires less information gathering. Okay. Function f is defined for all real values of x. For constant a, the average rate of change from x equals a to x equals a plus 1 is given by the expression 2a plus 1. Which of the following statements is true? Okay, that had a lot of variables in it, and a lot of confusion. The function f is defined for all real values of x. Okay, not really that important, but I guess if we use imaginaries, which we probably won't, it's important. For constant a, so a is just a number, just some number, we don't know what it is. Average rate of change of f from x equals a to x equals a plus 1 is given by the expression 2a plus 1. So over the interval x equals a and x equals a plus 1, so this is a distance of 1, right? Our rate of change will increase by 2a plus 1. So plus 2a plus 1. And then we increase, yada yada. Really confusing wording, but let's just read the answer choices. What are we trying to find? So we're trying to see, is it positive? Well, I don't know. Because f, we don't know what f is. It could be negative, right? We don't know this. We could have this negative thing and then it's increasing, yeah. But it's not. No. We don't know enough about that to know if it's positive. So upon reading our answer choices, so the average rate of change of f over consecutive equal length input values is increasing at a constant rate, or the average rate of change of f over consistent equal length input values is positive. Now, read and reread. Remember, the average rate of change is what we're looking at, not the function. I don't care about the function. We know nothing about the function. The average rate of change over consecutive equal length input value intervals is positive, right? So, average rate of change. Now it's 2a plus 1 that it changes by. But what if a is negative? See, because this could be anywhere. We could have a be negative 26, and then this is a plus 1, so it's negative 25. And then we change our thing, our rate of change. We're changing it by how much? Minus 50 something, 52 plus 1? Like, that is not positive. That is not a positive rate of change. And it's only going to get worse as you keep going. So, I don't think it's positive. Because if you think about it, as you get further away from the origin, a gets bigger, and then the amount that the rate of change gets changed by gets bigger, and bigger, and bigger. You know, and then if you go negative, the rate of change flips around, where it decreases, decreases, decreases. You know what that reminds me of? It reminds me of parabola, right? Origin right in the middle. So, line with positive slope, we just determined that it's not positive. Because if you go on the left side of the origin, a is going to be negative. And we're going to be plummeting. So it's not a positive line all the time. We know it's not positive. It's not a line with a positive slope all the time. Parabola, though, because a parabola, when you get farther from the origin, you shoot up. And then on the left, since it's negative, it goes down. And then on the right, since it's positive, it goes up. That seems correct. Average rate of change of the quadratic function p is negative 4 on the interval 0 to 2, negative 1 on the interval 2 to 4. What is the rate of change of p on the interval 6 to 8? Now, very important to read the question, because it's easy to look at it and be like, oh, and then you get it, and then you quickly blurt an answer, right? But what you want to do is look at it. Okay, so 0 to 2 to 4 to 6 to 8. This right here, negative 4. This right here, negative 1. This right here. Ah, what's this? What's this? What's this? Because 6 to 8 is what we're looking for. We skipped one. We need to determine what's here too. Alright, let's read this question again. The average rate of change of the quadratic function. Now, what's so special about quadratic functions? What's so special about them is that they are concave up or down. I don't judge. And their rate of change increases by a constant rate. So this negative 4 goes up by 3. This is quadratic. It will continue going up by 3. It will go up by 3, up by 3, up by 3, up by 3. Right? So we're going to have a 2, because that's up by 3. And then we're going to go up by 3 again, and we're going to have a 5. Now where it's really easy to get trapped is to say, oh, negative 4, negative 1, next one's 2. But you're identifying change on 4 to 6, not 6 to 8. You need to go one more. Read that question. Now here, I'm just going to come out and say this one's dumb. I think this one's pretty dumb. I forgot to read the question. An object is moving in a straight line from a starting point. The distance in meters from the starting point is selected at selected times. In seconds, is given in the table. If the pattern is consistent, which of the following statements about the rate of change which of the following statements about the rate of change of the rates of change of distance over time is true? Rate of change of rate of change. Cool. You know, you love to see that in your math problem. When they start using unitception, this is just great. You know? So first, let's find the rate of change for everything. Right? So, let me get rid of this. Doink. Rate of change here. Oh, well, we need to find the intervals to make sure they're equal. So this is interval of 2, interval of 3, interval of 5. So that's important now, so you don't get the rate of change wrong. This is an interval of 8. This is 8. So to find rate of change, what we do is we just do the y1 over y2, sorry, y1 minus y2 over x1 minus x2. Okay? So, which is y and which is x? Let's check this again. Distance in meter from the starting point at select times. So time is usually more often than not x, and as it seems here, distance depends on time. So we're going to treat time as the x. Let's just delete these real quick. So our y1 is 1 minus 9 over 1 minus 3. Negative 2 over negative 8. 4. Let's do the next one. 9 minus 21 over 3 minus 6. Negative 3. What is this? Negative 12. 4. Okay, starting to see a pattern here. 6 to 11. 6, nope. Remember y's first. 21 minus 41 over 6 minus 11 equals negative 5, negative 20, 4. So the rate of change doesn't change. So the rate of change of the rate of change, which is how much the rate of change changes, they need to invent some new words here. I'm going to invent a new word. I don't know if it's a new word, but I'm going to invent one. The coefficient of change. There, to quote that. So I'm going to call the coefficient of change how much the rate of change increases over select intervals. Right? There's no increase. Nothing changes. Coefficient of change is 0. Right? Rate of change of the rates of change, or in other words, the rate at which the rate of change is change. These aren't changing. So it's not 4. Although the rate of change is 4, the rate at which they increase or decrease is not, they don't move. It's like I'm standing here and I'm standing on this point 4, and then you're saying, whoa, he's going 4 miles an hour, that's crazy. Like, no, I'm just standing here. I'm not going anywhere. Same with here. So we can eliminate C and D. 0 meters per second is the rate of change of the rates of change. Now, apparently, unbeknownst to me, when you have rate of change of rates of change, you also have to go per second per second. Now you may be asking yourself, why? Honestly, I have no idea. That's just the unit you use, I guess. It's because it's rate of change per second, and then there's another rate of change, so there's another per second, I assume. I assume that's how that works. So if you somehow had rate of change, rate of change, you would have per second, per second, per second. It's just one per. They each get their own. And the object is neither speeding up or slowing down, because speed is remaining constant, rate of change is the same. There we go. Another one I got wrong. We'd love to see it. This one was pretty confusing. So, table gives values of a function f for selected values of x. Which of the following conclusions with reason is consistent with the data in the table? F could be a linear function because the rates of change over consecutive blah, 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 blah. I look at this 2, I look at this 1, I look at it going back down to 2. That is not linear. I'm so sorry, that is not linear. I have never seen a linear function that goes like this. No booty cheeks in my linear functions. So it can't be this, can't be this. So it's one of these. Now, these are the same, except for the equation. Right? Could be a quadratic function because the rates of change over consecutive equal length intervals in the table can be described as y equals 2x, or can be described as y equals 2x plus 1. Okay, let's bring this out. Bring this table out so we have something to work with. So, it's asking for the rates of change can be described by a function, either 2x plus 1 or 2x. Okay, well let's find the rates of change first. So the rate of change of this section, really easy since they're all equal intervals of 1, because we go 1, 1, 1, easy. So we go down by 3, so it's negative 3. Here, we go down by 1, because 2 to 1 is negative 1. And then here, we go up by 1. So what is our, what's it called? What is our coefficient of change here? My cool new vocabulary word. Well, that would be positive 2, because we go up by 2, we go up by 2. Easy peasy. So you may think, oh, it's 2x. Easy, that's what I thought. But we're ignoring the x. The x, if we plug it in, if we just go 2x, you have to realize that, let's plug in negative 1. So we have 2x, negative 1. Rate of change would be negative 2. I don't see no negative 2's. Meanwhile, if we did 2x plus 1, negative 2, negative 1, let me switch to color, that matches up. And then if you plugged in all these other values, they would match up too. So it is 2x plus 1. As much as I hate to admit it. Final question. The function f is not explicitly given. Dude, this question, I could just be wrong when I explain this. So take this with a salt lake, because I'm not entirely sure. Right? The function f is not explicitly given. The function g has been given by g of x equals f of x plus 1 minus f of x. Function h has been given h of x equals g of x plus 1 minus g of x. If h of x equals negative 6 for all values of x, which of the following statements must be true? Okay. What? What? Because h is negative and constant, the graphs of g and f always have negative slopes. Okay, so we've established that h is negative and constant in all these answer choices. So we're looking, are they both concave down? Are they decreasing? Do they have negative slope? Are they concave down? Is g one thing, f the other? We just need to find out if they're decreasing or if they're concave down, both, whatever. Okay. Now, let's write this up. So, we always want to visualize, just get things out. So, h of x equals 6, negative 6. g of x plus 1 minus g of x is equal to h of x, which is negative 6. So negative 6 equals g of x plus 1 minus g of x. Now what you'll notice here, one thing you can think about is, in a normal function, let's say g of x has value of x, right? That would mean it's increasing. If you were to subtract this point from this point, if you were to subtract x plus 1 from x, their y values, you get a positive number because this is higher, right? Because it's a higher x value, it should be a higher y value if it was increasing. But you see, you get a negative number. No matter what you do, it's going to be negative, which means that no matter what you do, the higher numbers of x will be below the lower numbers of x, which means it's a decreasing line. I know this is a little confusing to explain, so I'm going to try to re-explain it. G of x plus 1, let's draw this up. I have no idea. I'm going to spare you the yap that just ensued of me trying to figure this out, but I don't know. I don't understand this. It is the one question that I cannot explain to you. Maybe I'll come back with another video about it, but I can't explain this right now because I don't know. But yeah, maybe you'll get an interjection from future me that's just like, I got it, and then I'll explain. But as of right now, I'm stumped. I don't know. Hope you enjoyed. I'll try to shorten this video as much as I can, so it's not a hard, long watch, but hope this helped.